Topic 2, Lesson 4, Producing Useful Materials, pages 98 to 107 in your textbook. Many items we consume every day contain a yellow coloring agent called tartrazine. The powder shown here. Describe each item by writing natural or artificial under the image. Then we need to answer these questions. What other products do you think contain tartrazine? Explain your reasoning. So an example would be paint and processed foods are products that are available in bright yellow colors, but their natural ingredients do not combine to form such colors. Defend your claim. Some studies have indicated that tartrazine may complicate asthma and cause allergic reactions. Do you think that products containing tartrazine should be used by consumers? Why or why not? No, because someone may have an allergic reaction that could be dangerous. All right, so this is part of our natural or artificial section of the Connect It. So we're going to look at a couple of things. Not all of these, but most of these things are on your Connect It, just to make sure that you have the correct answers there. So all of these products are yellow. Some are naturally yellow, but some are artificially yellow because they are made with a synthetic coloring agent called tetrazine. So naturally occurring yellows, things like popcorn, lemons, flowers, some yellow flowers. Then there are artificial. We have soap, nail polish, and I'm not going to lie, I'm not 100% sure what that other picture is, but it's definitely not natural. What is synthetic? So synthetic materials are chemicals and resources that are made by humans. Synthetic material is one in which the starting substances are changed chemically to produce a material with different characteristics. So an example is plastic. To make plastic, petroleum is processed and chemically changed into plastic. The chemical synthesis is a series of chemical reactions used to change natural resources into synthetic products. What is natural? So natural materials, chemicals, and resources are made by nature. So a natural product uses a natural resource but does not chemically change the material as much. So examples, a wooden chair is more natural than synthetic because its shape has been changed but the material is still wood. Glass can also be considered a natural material. Glass is made by melting and cooling sand. The molecules that make up the glass are still the same as they were in the sand. Natural resources is building blocks. All products are made from natural resources. Natural products like a wooden chair and glass are made from natural resources like wood and sand. Synthetic products are also made from natural resources. Plastic is made from petroleum, which is pumped out of the earth. Petroleum is a natural resource. Natural resource is anything naturally occurring in the environment that humans use. Example is pure elements, simple molecules, or complex molecules. All right, so our math toolbox, nutrient concentration. So vitamin C is an essential nutrient for a healthy functioning body. This vitamin can also be obtained from food sources or in a synthetic form in a tablet. A tablet with a mass of 500 milligrams contains about 450 milligrams of synthetic vitamin C. A 180 gram or orange, contains about 106 milligrams of vitamin C. So we're going to compare the concentrations of vitamin C in the tablet and in the orange to determine the concentration. Calculate the percent of each object that is made up of vitamin C. So a tablet is 450 milligrams per 500 milligrams, which equals 0.9, which is 90%. An orange is 106 milligrams over 180,000 milligrams, which is 0.00059, which is 0.059%. So about how many oranges would you need to eat to get the same amount of vitamin C in one tablet? 450 divided by 106. So we have the amount of vitamin C in the tablet divided by the amount of vitamin C in the orange, and that is equal to about 4 oranges. So next, a carton of navel oranges has a mass of 18.2 kilograms. How much vitamin C do the oranges contain? So 18.2 kilograms is equal to 18,200 grams. Multiply that by 0.00059, which is the concentration, and you'll get 10.7 grams of vitamin C. Accidental synthetics. So synthetic and how it was discovered. Super glue. In the 1940s, a chemist working on plastic gun sights synthesized a material called cyanoacrylate that frustratingly stuck to everything it touched. A few years later, the chemist came up with an important purpose for the sticky material. What are the useful properties? They form very strong bonds without requiring water or heat. Nonstick coating. So in the 1930s, a chemist working on a new refrigerant came back to his lab to find small white flakes in a container instead of a gas he had been experimenting with. The chemist had unintentionally synthesized a new nonstick substance. Useful properties. High melting point prevents materials from sticking to it. Artificial sweetener. In the late 1800s, a chemist was working on an experimental compound. Forgetting to wash his hands before eating, he noticed that everything he ate tasted very sweet. Useful properties. Taste sweet, dissolves easily in water. Polymers. So a polymer is a long chain of molecules that are made up of repeating units called monomers. Natural polymers have been used for centuries: wool, silk, rubber, cellulose. Properties of polymers are that they're strong, flexible, and elastic. Now, synthetic polymers are made to provide clothes, building materials, and many of our material goods like plastic water bottles and toothbrushes. Here we have a list of a lot of different kinds of polymers, from natural cottons to soda bottles that are made from polyethylene. Technically, it's more than polyethylene, but we're not going to get into that. But we are going to go ahead and do our reading check. So why do chemists synthesize polymers in the labs? And the answer is that chemists synthesize materials that are not commonly found in nature or that are better suited for particular functions. Polymers are both strong and flexible, and that comes in handy for lots of different things. All right, so our model it. The structure of polymers. So the composition of a polymer, such as plastic, may be very simple, but the number of molecules may be huge, containing millions of atoms. We are going to use the model of the monomer to create a model of a polymer. So we have our monomer, the polymer takes multiple, and so we're just going to continue that pattern on and on and on, and yours should look something like this. So make sure that you have 2 empty circles and then a filled in circle above it. 2 empty, filled in circle. 2 empty, filled in circle. All the way to cover the whole thing. All right, so the impact of synthetic fibers. Synthetic fibers, things like acrylic, nylon, polyester, spandex, rayon, they all improve the characteristics of natural fibers like cotton, wool, silk. They're used to clothe people, they last longer, they're generally less expensive to produce, they dry quickly, and they clean easier than natural fibers do. All right, so impact of synthetic foods. Synthetic foods involve flavoring, coloring, preservatives, etc. They make food last longer and prevent rotting. They're cheaper and less time-consuming to obtain on a large scale, but they do pose potential health risks. So we're going to do this preserving food figure 5. So potassium sorbate is a synthetic food preservative often used in cheese, yogurts, and other dairy products to prevent mold growth. In the table shown, identify some benefits and drawbacks of producing and using synthetic food products. So benefits, we have that it can make food safer to consume, it can make foods last longer and preserve freshness, and it's cheaper and less time-consuming to obtain on a larger scale. However, the drawbacks are the health risks that can go along with it. Impact of synthetic medicine. So many medicine or drugs to treat illness are made up of synthetic chemicals. So there's a video here where it goes into information about Dr. Percy Julian, who used natural resources in soybean and yam to synthesize a molecule that would be mass-produced and go into medicine and save millions of lives. We have figure 6 here. This plant is Digitalis lanata, also known as Grecian foxglove. Eating even a small portion of the plant itself can be fatal. However, a compound from this plant is used to help patients with heart conditions. Chemists synthesize the compound into digoxin tablets that are safe to consume. So our reading check. A website publishes an article arguing that synthetic materials do not benefit society because they are created in a lab. Do you think the website is a reliable source? Explain. Answer. It isn't reliable. You have to acknowledge that synthetic products have benefited many people, even if the products also carry risks. All right, so we're going to go ahead and do our lesson 4 check. So 1, what is a synthetic material? And that is a material produced by humans that is the result of chemical reactions. 2, what type of changes must occur for pure substances to combine into new materials? Name a few kinds of synthetic materials that can be produced by this type of change. A chemical change must occur. Synthetic fuels, food products, medicines, and fibers can be produced as a result of chemical changes. 3, what is the difference between the structures of monomers and polymers? A polymer is a long chain of repeating monomers. 4, describe how the structure of polymers help to make them useful materials. Polymers are long chains. This structure makes them durable and flexible, which are 2 useful qualities. And lastly, 5, how would you respond to a friend's claim that chemists don't know what to expect when synthesizing new materials? So pure substances can be identified by their properties, and substances combine in characteristic ways. So chemists would know how to expect when synthesizing new materials. And that ends lesson 4.